Welcome to episode 4 of my Honda ST1100 Pan European repairs, and in this episode I'll be showing you how I put the engine back together. It's been several weeks since I stripped my ST1100 engine down, and I was really excited when the postman knocked with all the new parts. The brown shells look just amazing, exactly what I needed. These are very hard to get hold of, and I was told there's only 4 left in Europe. These shell bearings are new old stock and probably over 20 years old, so I examined them closely for any damage, but they were mint, so I'm really pleased with that. So the first thing I do is fit one shell bearing into the end cap, and it fits lovely, so I'm really pleased, so that should be just the job. So now I can fit the other shell bearing into the connecting rod. This is quite a fiddly job because the crankshaft's already fitted, so I have to tease the connecting rod past the crankshaft journal carefully, not scratching any of the journals. Then I can slide the bearing in nicely and it snaps in tight with a big click, which is always nice to hear. I apply a bit of assembly oil onto the shell bearing and onto the crankshaft journal to help it lubricate for its first few revolutions before the engine fires. Then I can gently ease up the piston up the bore until the big end assembly joins up with the crankshaft. I then lubricate the end cap bearing and place it over the connecting rod and push down as far as I can, ready for the nuts to go on. A little bit of assembly oil on the threads, as specified in the Honda manual. Sometimes this is done dry, but in this case it's done wet with oil for lubrication to get the correct torque of 26 pounds-foot. Before I use my torque wrench, I do them up with my T-spanner, just hand tight to sort of secure it down. I gradually tighten the nuts a little bit at a time each side to pull the end cap down square onto the connecting rod until it's tight. Then I can use my torque wrench, gently tightening up evenly each side until it clicks. Once it clicks, the correct torque is reached. I had a few comments about my torque wrench in the previous video, so this is how I check it to make sure it's reasonably accurate. If you measure exactly 1 foot, make a mark with a pen, then use a balance on the pen mark and pull it, it should click at 26 pounds. So I gradually apply pressure and you can see the needle go up, and it goes round and round and round to 25, 26 and clicks, so I know that's set exactly for 26 pounds-foot torque. This is a simple test that anyone can do if you're not sure about the calibration of the scale. I feel the play of the big ends by hand, and they all feel really good compared with before where I could easily feel one was more. So I think I'll just check it with my DTI using the same method that I used before, and before I had 0.08mm clearance, and now it's showing 0.05 just. So that's an amazing difference, just changing the shell bearings. I'm bringing it straight back into the standard recommended clearance, so I'm really pleased with that. I gently rock the crankshaft back and forwards a few degrees. You can't go too many because the camshafts aren't connected and you'll bend the valves, but just a little bit's okay, and it feels really smooth. So now I can put some gasket cement on the bottom crankcase, ready for lowering it down. But before I lower down the bottom crankcase, I mustn't forget this breather diffuser. This just slots in here and stops the main splash from the crankshaft going up the breather pipe. Then I put a bit of assembly oil on the main bearings and it's all ready to lower down. I lower it down carefully, making sure that it goes on square to the crankshaft so I don't damage the shell bearings. Give it a slight tap and then start putting in all the bolts. There's so many and they've all got to be torqued down to the correct specifications to prevent distortion of the crankcases. The crankcase bolts come in various lengths and diameters, and they've all got different positions where they go on the engine, but you can't really get it wrong, because if it is wrong, they're either too long or too short, and you just move them around till you get it right. With all the crankcase bolts tightened hand tight, I go around with my torque wrench to tighten them up to the correct torque. I borrowed this torque wrench from my friend Henry. He's had it for years and never used it once, so I thought I'd put it to good use on this engine rebuild, as my one's a little bit old and battered. With the crankcase bolts tight and 1 cup of tea drunk, it's time to fit the oil pump. This slots down onto the crankcases and slides into a journal at the front with a rubber O-ring that makes it a tight fit, and it snaps in with a big click with all the holes lining up afterwards just perfect. So I put in the first bolt nicely, then I drop the second bolt down inside the engine, which is really annoying, but it's not a problem as I've got a magnetic device. You just extend out like an aerial, pop it down inside the engine, stick it onto the bolt and pull it up. This is no good if you've got titanium or stainless steel bolts, but mine are steel, so it's just perfect. And there it is, recovered and back in its correct hole. That was close. I then fit 2 new O-rings for the main distribution gallery. This bolt's in place with 2 bolts. I tighten these by hand with my T-spanner. With the oil pump secured in place, the next thing to do is to fit the drive sprocket on the front. With the sprocket in place on the shaft, I have to put a Loctite on the threads because you don't want this nut coming undone when the engine's running because you'd lose your oil pressure and it'd jam up and make a big mess. The oil pump's driven by a Hivo chain. These are sometimes called sealant chains. They were actually invented in the 1920s. So the next thing I fit is the primary transmission shaft with its damper. This slides in from the back of the engine through a bearing at the front. I put a drop of oil on the shaft, then I can slide on the oil pump drive sprocket and clutch centre bearing. There we go, that feels really nice. It's always good to check things rotate at every stage of an engine assembly, just to make sure. The next thing I'm going to fit is the alternator drive shaft. This has an O-ring that I need to change. I bought new old stock O-rings, so first I remove the old one, then I can replace it with a nice new one, and this will prevent any oil leaks. I like to use genuine Honda parts where possible, because they just fit. I use a bit of silicone grease to rub onto the O-ring to make it slide into the groove nicely. This also helps the whole assembly slide into the engine without pinching the O-ring. With the O-ring fitted, I just check it spins freely with no notchiness, and it does. The bare ends feel brand new. But now I've got to line up the damper on the sprocket. The sprocket has a special damper to prevent backlash rattle, and you have to pre-engage and twist it. So what you do, you put a 6mm drill in the hole, then use a screwdriver to line the teeth up, and the drill drops into the hole, locking them both together, and then you can slide the assembly straight into the engine with no problems. And once it's in, just pull the drill out. And here you can see the teeth perfectly aligned. To give the O-ring the best possible chance of sliding in nicely, I smear some more silicone grease on the surface, and then slide it in, engaging the bearing at the back, and give it a sharp tap with my hand, and it snaps in place. Then the drill is really loose, so you can just pull it out, and the teeth are engaged and lined up nicely. The next thing to fit is the gearbox. This has a special aluminium gasket, complete with an orifice control port, so it has to be replaced as a genuine item. I carefully unpack it from the wrapping and place it onto the engine. It fits really nicely over the 2 location dowels. The whole gearbox assembly then just simply slides into the back of the engine, engaging with the primary transmission shaft and the 2 dowels, and then you just replace the bolts. As simple as that. It's a really good design. With all the bolts fitted, I go around with my T-wrench and do them up hand tight evenly all the way around to pull the gearbox up square against the engine. Then I can use the torque wrench to set all the torques to the factory specification. With all the gearbox bolts tightened, I can connect up the neutral wire because that's difficult to do when the alternator's in place, and that's the next thing I'm going to fit. So I get a new O-ring, put some silicone grease on it, and fit that to the alternator, ready to slide onto the engine. I offer up the alternator, engaging the spline drive shaft in the centre, then gently pushing until the O-ring engages with a little snap, then gently rotate it backwards and forwards so the bolt holes line up, and fit and secure the 3 bolts, torquing them up with a torque wrench. I've been working on the engine for quite a while now, so I pop in to see what Tracy's up to, but the back door's open, so she might be in the garden. So I walk outside, and she's checking the hedgehog feeding stations to see if they've come last night, and this one's absolutely clean, there's no mess, all the food's in the same place. And I look around, and the pigeon's having a bath in the bird bath with his wings stuck up in the air. Proper weird. I don't know why they do that, but they seem to do it a lot. When we look in the other hedgehog feeding station, there's a little bit of nibbling around the food, so we might have one. We'll have to check the camera footage later. So back in the garage, it's time to fit the starter motor. This is just like the alternator, it has an O-ring and it snaps in place. It has a heat shield because the manifolds pass very closely to it. And the stainless steel heat shield just snaps on with 3 bolts, or 2 bolts and a nut. With the starter motor fitted, the next thing I want to fit is the sump. This bolts on the bottom of the engine obviously, but before I can do that I've got to put the oil strainer with its new rubber seal. Here's the old seal next to it and you can see where it's pinched during assembly, so I very carefully put the new seal over the strainer, pushing it down tight against the shoulder, then put some silicone grease on it to make sure it slides nicely onto the oil pump without any pinching or chaffing like before. I actually found this quite hard to do, so I can see how it's done before. You have to push it down quite firmly and evenly and gently until it seals nicely. I carefully unwrap the new sump gasket from the packaging and place it on the engine, and it fits just perfect. I'm really pleased with that. It's always nice having the old stock gaskets. With the gasket in place, I carefully fit the sump, engaging it with a strainer as I push down, then fit all the screws. I go around with my electric screwdriver to tighten them up. This makes easy work of it, and then I can finally torque them down with my T-spanner afterwards. I'm now ready to fit the clutch. This is fitted as a whole assembly, sliding it carefully onto the main shaft. You can only engage it down until it hits the front crankshaft sprocket, then you've got to align the teeth like we did with the alternator. So I put a screwdriver in the hole, you can twist it around until it engages, then the clutch gently slides back. It only goes back a little way because it hits the drive sprocket for the oil pump, so you have to rotate that by your thumb until the dowels line up and it snaps back in tight. And you can always check that the front sprocket aligns nicely because it's flush with the drive sprocket. The next thing to fit is the spring-loaded Bellevue washer and the central nut. And once the nut's tightened, you bang over the nut into the little dent in the centre of the shaft to make sure it'll never come off. I can now fit the 5 clutch springs over the raised bosses and the front central plate with the bearing. This is held in place with 5 screws. I tighten the screws evenly with my T-wrench until the plate hits the stops beneath. So that's the clutch fitted, so now I can fit the intermediate clutch cover, but first I put some silicone grease on the oil seal that runs on the crankshaft, just to make sure it slides on nicely without damage. The cover slides down nicely, locating on 2 location dowels. Before I fit the front clutch cover, I fit a new pushrod oil seal. This just pushes in nicely with a bit of silicone grease. A new gasket is placed on the location dowels, ready to fit the cover. The cover fits straight on perfectly, and then the screws can go in to hold it all in place. Some of these screws go through both covers and screw directly into the crankcases. When there's a lot of screws to tighten, it's so much easier with an electric screwdriver. Then I use my T-wrench to finally tighten the screws. The ST1100 has a cam belt to drive the camshaft, so now it's time to fit the cam belt drive sprocket onto the crankshaft and its special timing disc and bolt. The timing disc locates into the Woodruff key slot, and this is what you use to line up the crankshaft for top dead centre using the little dot, and that lines up with a little point on the crankcases. It's really important these two line up perfectly. Then I can check that the camshafts are in line on both sides before I can start putting on the belt. Before I can fit the timing belt, I need to refit the water pump. This nestles between the centre of the engine and has a special seal that goes around the back. I apply some silicone-based gasket sealer in the groove, then press the seal in tight to hold it in place. And the little round O-ring is the crankcase breather. The water pump can now be fitted, pressing it down firmly between the 2 cylinder heads and the crankcase. It's quite a tight sliding fit, because it has to go past some rubber seals, and then you can put in all the screws and tighten them up, pulling it down tight against the crankcases. But I look at the door, and Tracy's giving me a cup of tea. That is so nice. But I wonder if I'm going to get a cupcake as well. Oh yes, and they are so nice too. So I stop to eat my cupcakes before I carry on. I finish eating my cupcake, then I have to put on some fresh clean gloves ready to pick up the cam belt. I don't want to get any oil or traces of grease on the cam belt before it's fitted to the engine. Before I fit the cam belt to the engine, I need to install the tensioner. This is a spring-loaded roller. It's quite fiddly to fit. You have to hold it against the spring tension to lock it into the loose position so you can fit the belt, then release the bolt afterwards to tighten it. With the crankshaft and camshafts in their correct position, the belt slides onto the crankshaft pulley first, engaging the teeth, around the water pump, around the camshaft, around the idler, around the other camshaft, and then around the adjuster. When it's fully fitted, you can release the spring tension and it should hold it all in place. With the belt fitted, I can now release the tension on the tensioner using the spanner, and the roller will spring across and tension the belt to the correct tension. With the tensioner tightened, the next thing I do is check the alignment marks of the camshaft pulleys and the crankshaft pulley to make sure nothing's moved. With all the timing marks confirmed, I then use my socket on the crankshaft bolt and very carefully turn the engine over 2 revolutions to make sure everything goes round okay. At the end of the second revolution, I stop with a crankshaft alignment mark lining up with the crankcase and check the 2 camshaft marks, and they all line up just perfect, so I'm really pleased with that. With the cam timing confirmed okay, I refit the guide plate, securing the central bolt tight. The last thing to do is to fit the plastic timing covers at the front of the engine, then I can turn it up the correct way. So here's the finished engine, and I'm really pleased how it looks. It looks so nice. So now I'm going to screw on an oil filter and put some oil in it. I unscrew the filler cap and start pouring in the oil, monitoring the sight glass as I go to make sure I don't overfill it. There we go, that's just perfect, just below the top line. With the oil at the correct level, the next thing I'm going to do is turn the engine over on the starter motor. So first I remove the spark plugs, then I'm going to kick the oil pressure switch through a bulb to the battery, so when the oil gets flowing around the engine and reaches pressure, the light goes out, and I know everything's good, with minimum load on the crankshaft because there's no compression with the plugs out. You can hear the tone of the engine drop slightly as the bulb goes out. That's due to the oil pressure, and I'm really pleased with that. It goes out straight away every time I crank the engine. So now I can replace the spark plugs. With the plugs fitted, I crank the engine once more and feel the suction on each individual inlet port, and it's really good, so I'm really pleased with that. With the engine always primed, I now have to top up the level. That's better, it's just below the upper level, just perfect.
Well, thanks for watching. I hope you enjoyed it. In the next episode, I'll be getting the engine back into the bike, if I can lift it up. It's really heavy, but I'll work it out somehow. Anyway, see you all next time.
Well, we only had one hedgehog come and visit, and he had a little tiny nibble and then went away, so I think they're all hibernating. But anyway, they'll be back in spring.